Hello, welcome to Sydney Testers. Now, for our next event, we're having a great discussion about AWS Lambda with Robert O'Neill Taylor from Amazon, based here in Sydney. Let me just go through our various introductory slides, and then I'll take you through and hand over to Robertson Taylor, who will go through his presentation on AWS Lambda. So here we go. As I said, this is a hands-on guide to testing AWS Lambda functions with Amazon's Rob O'Neill Taylor. And if you want to tweet the event, please do so at Sydney Testers or Sydney Testers or hashtag SydTestRTaylor. Obviously, the more people tweet and hashtag the event, the more interest we have about Sydney Testers and AWS Lambda and Robertson Taylor himself. And it's all good for the group. So that should be 5:05, I apologize. But there's a 5-minute introduction by myself. My name is Paul Maxwell Walters. I am one of the co-chairs and I'll be presenting this event tonight, or chairing the event tonight. Then we'll have a talk by Robertson O'Neill Taylor with about 10 or 15 minutes of Q&A at the end. If you want to raise some questions, please do so in the YouTube live chat. I will be going through the live chat, and any questions posted there within the time limit that we've set, we'll go through at the end. So who are Sydney Testers? We're a group of volunteers with a focus on improving and enhancing and promoting good quality testing here in Sydney. We organise monthly talks, sales, and other events for the Sydney testing community, and recently online. With COVID-19, unfortunately, being a really serious problem for doing offline in-person events, we'll be doing online events for at least a couple more months. Now, we have a wide range of international speakers and local speakers. Recent speakers have included people such as Michael Bolton, Trish Koo, Richard Bradshaw, and Rich Rogers. And if you want to get involved, we're always looking for people to join our committee. We're always looking for people to help organize events. Please let us know. Please speak to us. A bit about Robertson O'Neill Taylor. He has a PhD in computer science with a focus on modeling and simulation and theory from Georgia Institute of Technology. He's worked as an SDET in a number of distributed computing systems. The majority of his work in software testing was design and building automation frameworks. He's also worked as an AWS Cloud Support Engineer, as an accredited subject matter expert for AWS Lambda, working to help some of the largest companies in the world troubleshoot and recover from production impacting issues. He now works as an AWS solutions architect, helping to design scalable, robust, distributed systems. And we'd like to thank our ongoing sponsors, TestEd. Please let me introduce Robertson O'Neill Taylor.
Hey everybody, thanks for
Rob, thanks a lot for joining us. I'll just pass over to you now.
Cool. Thanks for joining everybody. I really appreciate the platform, and thanks for attending, taking some time out of your day today. So yeah, today we're going to be talking about testing AWS Lambda functions. We're going to be chatting about, how to actually build and test production-grade software that's sitting on AWS Lambda, and some of the challenges you can face when doing this, some of the tools that are available to help you do this, and hopefully speed up your acceleration of using the service, or potentially help you, with some problems you'll be having right now. Cool. So we're going to start off with a little introduction to serverless for the people who don't know what serverless is. We're going to chat about the actual Lambda programming model, talk a bit about distributed systems and why they can be a challenge for testing, how that can impact the testing patterns you have for Lambda, and the actual unit integration testing of AWS Lambda functions, where we have a little hands-on lab, have some code samples you guys can look at. Not promising beauty, not promising perfection, but it will get you some practice with the actual programming model, and understand a bit more about how to actually get hands-on and dig into it. So basically, when we chat about serverless, what we're really chatting about is an operational model, not really a compute platform. Like a lot of people think that when we talk about serverless, we're just talking about compute. It's not really the case. In reality, what we're talking about is a platform where you have no real provisioning of infrastructure. You're not managing the deployment of software on those servers. You're not managing security patches for those servers. You're not maintaining a fleet of those servers. You're really offloading that burden, that undifferentiated heavy lifting onto AWS, or in this case, AWS. And you want us to handle the actual scaling. You just want your customers to be able to actually use your services, and you want to pay for what you're using, not what you're not. So in a traditional model where you might have a server, what you're really paying for is the existence of that server, not the actual utility you're getting out of it. Whereas serverless kind of flips that pricing model into something where you actually pay on a per invocation basis and for the amount of time that you use and the amount of resources that you're using. So AWS Lambda is a really great example of this, but it's not the only serverless technology that's out there, not even within AWS. And, like we're talking about, you don't want to worry about availability either. You just want to be able to actually say, I have code, I want to run it, or I have a messaging queue that I just want to receive and send messages, or I have, file storage that I just want to be able to put stuff in and get stuff out. And that's really the whole model. And for a bit more context there, for what it looks like inside of the AWS space, you actually have services like, AWS Fargate. It's another good example of a compute service that's maybe a bit further away from serverless than Lambda, but still very much just, you're scaling up. AWS is doing that for you. We're managing your containerization side of the workflow. And all you're really worrying about is having containers, having task definitions, and running your code. But more interestingly, I think that it's important to bring home that serverless isn't a new concept. We have services like Amazon S3, which are some of our oldest services within the AWS platform. And Amazon S3 is a prime example of a serverless service. Basically, for those who don't know, you just put a file in and you get a file out. And it's really straightforward. You pay for actually having the storage space, and you pay for the data transferred out of the AWS network. But you're not paying for, just having a hard disk somewhere that maybe you're not using the whole capacity for. You're just paying for the files you're storing. And we're not going to talk about every service here, but you can see that there are a number of services that really fit that serverless persona, and we'll get a bit more hands-on with a few of those later today. So where Lambda really fits here is very far on that serverless spectrum of, you're saying, I'm fine with AWS giving me just the platform to run my code. I don't really want to have to think about the amount of memory that the amount of resources and the proportion of resources. I just want to be able to say it needs to have more power, less power, and it can run my code. I just want to be able to say that there's actually code that's sitting in AWS that can be run from a variety of different services in response to a variety of different events. And that's all I want to manage. Whereas Fargate, you can see, like we talked about before, you start getting into things like actually having to worry about, potentially having security and security configs, updates to those containers, the task definitions, kind of do a bit of software-defined networking, and all of that sort of stuff that you start to worry about there. And then as you get further and further down the platform, you eventually wind up with services like EC2, which is it's a great service, but you're worrying about a lot more. You have to worry about actually maintaining the security of your EC2 instances, staying up to date with patches, potentially rolling over to new versions of operating systems, making sure that you're compliant in the way that you're using EC2, which is something you have to worry about with Lambda as well. But there are more little snafus with EC2 that you have to worry about. And at the end of the day, you have to worry about things like scaling as well. You have to actually make sure that you understand entirely how your application is being used, how it needs to scale up, how it needs to scale down, which events to scale it up for, what size your instance should be. And these are all things that aren't particularly differentiating you from other businesses. the ability to say, I have a memory intensive workflow and I need to have this instance with this amount of RAM is not particularly separating you from other businesses. And you kind of spend cycles thinking about things like that. And EC2, it's a great service and it gets you away from thinking about on-premise hardware and, can my data center survive X, Y, or Z event? But it's still a lot more to think about than something like Lambda, which is truly just running your application code. And this modernization really changes how you work. And if you look at a lot of the intro to serverless slides from other talks, most of this focuses on business value, but I think that it's a real mistake as from a development perspective, you're really changing what you're working on day to day. And, as a builder, someone working on building out test suites or someone working on building out actual applications, you're not wanting to think about, how many servers do I need to have in my, test fleet to be able to handle my peak load when all my devs are pushing code. That's not really something that's helping you scale out. And your devs don't really want to worry about, the actual underlying hardware and how their potential, code changes might tax that past where it can go. It's much better to have an increased cost for a little bit than to have a production down outage because of, a misunderstanding of server hardware or just failure of server hardware. And Lambda gets you to stop thinking about that. And from an operations side, we've also kind of talked about this for a long time where we say, traditional application operations like server management can kind of go entirely away. We can do these no ops as a buzzword that gets thrown around a lot. And as serverless progresses, I think that misconception has changed a bit where, it's not no ops really, it's just a different kind of operations. And we'll kind of see a bit of what that is today and how you in a testing role can actually help out with that operational load and help make that more seamless for your internal customers and your external customers. Cool. So that's kind of an overview of what's actually happening with serverless. But let's actually dive into Lambda and how that really works. So essentially, we have these serverless applications. Here we have a Lambda function where you can have a variety of different runtimes that are supported from Node.js, Python to more like statically typed languages like Java or C#. Or you can bring your own. If you want to run REST on Lambda, there's a custom runtime API. You can really do whatever you want to do. It's up to you. At the end of the day, it's infrastructure that's running your code. And if you want to provide it with a bootstrap script, that's something that you can totally do with the features that are available today. And something that's really nice about Lambda within the AWS ecosystem is, you can have a traditional model where you have an API, someone calls your API, you run some code, you return a result. But you can also have these event-driven architectures that respond to infrastructure state. So that's something that's really interesting when you start thinking about it from a testing perspective. Because this enables your test suites to have these nice little hooks for when something breaches the performance threshold. If you're really into performance testing and monitoring there, you can say, well, it's time to reject the build and trigger a rollback and start investigating a regression. Or if you have a change in underlying data state that and a table that shouldn't be accessed, or the change in data violates the assertions you have for what should be in that table, you can expand your role for testing there as well. And this is all stuff that you can do without any management of infrastructure. And beyond that, you start looking at the downstream services you can interact with as well. And that can be an internal service. Maybe you guys have an application that you want to reach out to from your Lambda function, and you want to chain these application interactions together that way. Or maybe you have managed AWS services. Classic example might be simple queue service, which is essentially just a service that queues things. So you can push a message there and have this decoupling architecture. And this is all seamless and out of the box. And for those of you who are familiar with AWS, Lambda does integrate with identity and access management. So you can control which services you can actually reach out to, or if your endpoints are within AWS, you can control which endpoints are potentially mutable by the function, and what actions can actually happen from there. It's a really cool model. So now that we've covered that, we'll kind of get into what this actually looks like. And it's not surprising, it looks like code. It's just a pretty simple Node.js function here. For those of you who are familiar, it should be pretty straightforward. But since the rest of the talk is in Node.js, I'll cover a few of the key concepts that are going on. We have this constant AWS. It's basically requiring the AWS SDK. You can think of this as an import from a lot of languages. And basically, this gives us access to the individual clients. So for here, in this example, we're accessing the S3 service. So we create an S3 client. And notably, we create this outside of that handler. So if you see down there, there's that exports.handler async function. That basically is what's going to be run every time the function's invoked. And the stuff that's outside of that handler can actually be shared and reused between execution contexts. So this is one way you can avoid repeating execution of code that's not necessary. And Lambda does do a best effort attempt to reuse these environments. So for instance, in this case, if we ran this function twice in the same execution environment we're used twice, we'd have, we wouldn't call the S3 client creation step again. We'd have that connection pool, we'd have that access to that service, and we'd just be able to list our different S3 buckets and return that value back to whoever's calling. So to tie that back in with what we just talked about, if this is something that potentially you don't want someone to be able to do in your account, you can lock this down with identity and access management. So if you don't want people to be able to list your buckets from Lambda, you can stop that arbitrary execution by restricting the actual access that Lambda function has to your AWS account. So the other little piece of here that we haven't talked about is this event. So this event is the payload that's actually coming into the service. And if in the case that we have an API gateway, that's just, someone's calling an API, it's coming in, the event would be the payload that API receives. There's a context object that we'll see in a few other methods. It's not specifically required in every execution, but it does give you a lot of information that's actually pretty valuable from a testing perspective, like the actual request ID, the log group that it's writing to. So if you want to pull those logs, you can get that from there. And you can get things like the amount of time that's actually left in an execution. All of that sort of stuff is available from the context object. Perfect. So we have this lifecycle of a function invocation that I was touching on a second ago. And basically, the way that this works is when you trigger that function execution, you create the clients, you create all the stuff outside of the handler scope, and then that environment, it sticks around. We're not going to just toss it away indiscriminately. You're not paying for it sitting around, but you can reuse it the next time that your function's invoked. So in this case, let's pretend we have an arbitrary execution, happens 5 times. You can see we have this overlapping execution with environments A, B, and C, and there wasn't a chance for reuse there. So we had 3 concurrent executions there by necessity. But then after those executions are finished, we can see that actually, execution in environment A is done. So the next invoke can actually go into execution environment A, and we can reuse whatever was declared outside of the function handler before. Same with environment C. And this really allows you to reduce the amount of time that Lambda functions take to invoke. If you had to establish these TLS connections every time, it might not be a practical model. But in this case, we see these cold starts don't happen particularly much in production workloads generally. But from a testing perspective, this is actually really interesting. So when you look at this, what should be blaring in your head is I have shared state. So these functions aren't truly stateless unless you're making it stateless by putting everything inside of the handler. But if we flip back here, there are a few interesting things that can happen with the code outside of the handler scope. So from the perspective of downstream systems, this isn't interacting with it very much. Like, let's say there's a 15-minute pause in between that shared environment use for environment A. All those connections to downstream services, they're just hanging from the perspective of whoever they connected to. And from the execution environment's perspective, not much time has passed, those connections should still be open. They haven't received any close events. And so that's one example of how state can kind of come into this and should be something on your mind when you're looking at these Lambda functions. And beyond that, you can, a typical mistake that I see people make when they're first getting into this model, even some of, the largest customers I've worked with, I've had production bugs where, someone says, Lambda's not working, and then it winds up being somewhere and, some module that was imported outside of the handler scope, their state that's being stored. So that should be one thing that's going through your head as you're looking at these. For instance, if I had a variable sitting outside of this handler scope that was just a JSON object, and I was using that inside of my methods, that's really something that you should be worrying about testing and making sure that the workflows surrounding that object are appropriately handling it at that state. Okay, so that really covers that piece, but it's something to really make sure that you have your mind wrapped around, because it comes back to bite people, even who understand it. And as a tester, this is somewhere that you can really provide value by not allowing your developers to make this mistake. Perfect. The ways that you can actually test these serverless applications tie into the programming model, obviously. One way that's pretty uncommon, but I figured I'd touch on it here just to make sure that people are aware of this as a thing, is contract testing. So contract testing is really something that is a staple in a lot of distributed systems, particularly with event-driven architectures, where you, as a consumer of an API or as a downstream call of an API, you can assert that the calls coming into you are actually in line with what you're expecting from that service. So to give you a more concrete example, say you have a team that's working on payment processing, and you have a team that's working on sending out emails for confirmed payments. These are likely separate services. They're separate microservices. There's very little reason in a microservice architecture that those should be coupled together. But the actual events that are coming through to that email service, there needs to be a way to assert that they actually follow the spec that's been agreed upon by the team that does payment processing. And it might be a forward compatible spec, it might be a backward compatible spec, but the typical way that this workflow is actually done is by having, a shared repo or something where the consuming team is actually the one that gets to have control over those objects in Git and pull them in during integration testing and say, well, if you violate this, you can't pass, NTAG. You have to go back, work on it again. We're not deploying this to staging. We're not, going to prod with this because it'll break the contract. And it's a really powerful pattern that I know in the places that I worked, I didn't see it very much. And I can think of a lot of bugs that would have been avoided by having this pattern employed. And there are services that can help you out here. A lot of production event buses can help you streamline this behavior. For instance, EventBridge is one of our newer services, and EventBridge does allow you to have a schema registry where these events are stored in a schema, and you can control who can write to the schema, who can modify that schema, and that's one way you can actually get this contract testing out of the box. The typical, nitty-gritty, not managed way that I've seen customers do it is via Git, and that works fine. But it's not something we'll dive too deeply into. We're not going to look at it in the demo, but it is something that is a valuable pattern to keep in mind and just have in the back of your pocket if you do start seeing these kind of bugs. And when we actually get to a Lambda function, there's a lot of confusion here where with event-driven systems, people can kind of tend to just want to pass in the event and assert the output is fine. But it's the same as any sort of production application. Just think of it as a microservice. And the logic that you expose in that function can either be, this the typical business logic that you would from a normal application, and you can unit test that in a completely normal way. Or if you can go the route that I've seen some customers do and just pass in the event and only do impact tests, and that's really an anti-pattern. We'll cover that a bit more later, but you can use whatever framework you want here. You're not really limited. It's not something that is an issue. If you want to use PyTest for Python, if you want to use Jest for Node, that's all perfectly acceptable. Sorry, my lights just went off. But basically, there can be a few little changes to change what's publicly accessible and externally accessible from these functions. But if you find yourself shying away from unit testing with Lambda, I'd say that's probably a bad smell. And if you have people internally who are telling you, you can't unit test with Lambda, feel free to tell them that they're probably wrong. And yeah, so ways that you might approach that might be breaking functions down into more modular pieces, or just typical things you do to get granular unit tests at a method level. And when we start integrating with downstream services, that's when we start getting into integration testing. And integration testing is a necessity for reliable distributed systems. No one's going to deny that. No one can deny that. But one of the things that I learned really early on was that the longer your tests take, the less likely people are to run them if there's any way they can get around it. And integration testing is no different. And just think that each time that you're running these, unit tests potentially is a build that's not going through the prod pipeline. It's not blocking someone. And if you don't have a pipeline, people just won't run them a lot of the time if the tests take too long. So the test pyramid really is your friend here. And but there's no denying that integration testing is important, and we will cover a bit of how to do that as we look to the hands-on piece. But to understand why, we really have to kind of dive into what distributed systems are and how they work, and kind of common problems that you might see in a distributed system. So when we look at distributed systems, here's an actual production system that's running Lambda. This is how Lego is deciding to process their order delivery system. And you can see we have a lot of different functions here. We have 7 different functions, some of which are event-driven. You see that there's that event relay at the start. Some of which, all of them really event-driven. Some of which are event-driven from upstream services, and others that are using the event bus. And some have bidirectional communication with the event bus, some just publish to the event bus. There are a lot of moving parts here, though. It's undeniable that there are a lot of moving parts to this application. And if you didn't understand why integration testing is essential, I think this diagram will kind of explain. You can test that login function as much as you want, but until you know how it actually integrates with the other 7 functions in this architecture, you probably haven't asserted too much about what's going on. So when we look at this, we have those 4 functions at the bottom that have those bidirectional communication, where they're consuming from Event Bridge and they're writing back to Event Bridge. And each one of those might trigger more downstream events. And you might have different teams working on each of those components. So you can see that just passing the unit test isn't going to be enough, because we actually have to have an integration test suite that can closely match the desired production environment state. And paradoxically, the kind of best place to have that would be without infrastructure. If we could provide that to developers on their local machine before it ever goes into a CI/CD pipeline, or before it ever gets to your staging environments, that's really ideal, because that's infrastructure you're not worrying about. That's a higher velocity of development for your developers. And figuring out a way to do that without mocking is really hard. And that's where you'll see a lot of automation frameworks come in. I've worked on a few services that kind of try and fill this gap. And every time it's a bit of a challenge. It's a real challenge. And figuring out when it's appropriate to mock out individual pieces of this isn't straightforward. So for example, if I mock out Event Bridge, it doesn't quite work because I can have that, what's a good example here? I can have that payment authorization event come through, and I can send that to and from Event Bridge, but I can't tell how that interacts with the other stages of the application, other versions of the application at this juncture. And building out a mock that can kind of do that is a bit of a challenge, but there are some tools available within AWS that can help do that. But at the end of the day, there does generally need to be a staging environment for most testing applications, especially ones that are distributed. And that's where things like infrastructure as code really, really shine. So CloudFormation is a fundamental piece of AWS, and it's going to be fundamental to understanding our demo later as well. So it enables infrastructure as code by providing a declarative language to say how you want your infrastructure to look. So an example would be, I want to have 7 Lambda functions in Event Bridge. You can declare that in a JSON file or a YAML file, and you can actually automate the provisioning and update of those resources by creating individual change sets, and CloudFormation manages the diff of that pretty much. So you deploy the first time, it deploys all the resources, and then it manages updating your infrastructure as it changes over time. So with Lambda, this might be, a code change would trigger a new function deployment, or even an upstream service change. Like let's say maybe we decide that order and customer update table, we don't need that anymore, and we actually want to have a queue that sits there. That's something we could define in CloudFormation, and it would be a really trivial infrastructure change in CloudFormation. So to see how that actually works, here's the real flow of what goes on. And you have your code here where developers can write templates and YAML or JSON. And you can also generate code via macros and transforms. We'll see how that works with SAM, Serverless Application Model, in a little bit. And there recently, we have the higher level language, AWS CDK. For those of you who know the difference between declarative and imperative languages, it's imperative. You tell it how you want things to look, and it basically figures out how to actually declare that infrastructure and deploy it for you, which makes the whole process of infrastructure as code much less painful. And we'll get hands-on with that later as well. And after that, you can commit that into a repo, maybe you track that somewhere else. But realistically, with CloudFormation, what you're doing is you're uploading this into S3. You're providing it by an API call to a service, and then the service itself can actually execute creating that change set and deploying that. And you can see that the rest of this is talking a bit about CI/CD pipelines, and it does fit very nicely there. You'll find that after you have this declarative infrastructure as code, making an actual CI/CD pipeline is not a painful process. It's really probably one of the easier pieces after you have the existing CloudFormation template, and it provides so much value. Places I've worked at that have gone from having no continuous integration to even just having continuous integration, not even deploying the code to production or even delivering it as an artifact for staging. It's done wonders as far as velocity goes. So if you don't have that in production today, I'd really encourage you to start doing a bit of research there. And if there is interest, I'm happy to give a bit of a talk about that or answer some questions about that after the talk here. But there's a higher level abstraction on top of that makes it even easier than CloudFormation. CloudFormation can be a bit verbose. Templates can be quite long and nested, and especially with serverless, where you have like I talked about before, you have that function, you have the code, and you have roles, and you have access control, and you have a lot of different pieces. Serverless application model is basically an abstraction that allows you to define these functions and DynamoDB tables and API gateway, instances, all of these little serverless components that make up the AWS ecosystem really easily. There's an example of 20-line SAM template you're going to see in a second that declares a functioning API with a backing database, which it's crazy if you think about it. And the nice thing about serverless application model is it truly is an abstraction on top of CloudFormation. So if you do start shifting your stack towards serverless and you do have existing CloudFormation templates, you can bring those in and just kind of start taking advantage of the abstraction without any of the pain of getting it done in CloudFormation. But those are just the templates. So the templates give us that shorthand. But in reality, from a testing perspective, the real value here is the SAM CLI. Because this does a lot of what I was talking about when we were on that event bridge slide, providing this local mock that kind of does actually define interoperability between services. So SAM CLI, you can actually start, attaching a debugger to your deployments, which is not something you can really do out of the box with Lambda. You can actually start testing those invocations locally. So, you can say, I want to invoke my Lambda function and it has a DynamoDB table. I don't want to worry about mocking that. And SAM will handle that mocking for you. It'll create a mock API. It'll create a mock DynamoDB table and provide an endpoint you can call and use in your integration testing, which is just a beautiful solution because it really simplifies the whole framework creation that would have been a very painful process before. And it gives you a very simple CLI to do this from. So to see what a template would actually look like, you can see here we have this transform, which basically tells the service that we're using the serverless abstraction. And we have a serverless function here. It has a function handler. So this is basically the method that we're going to call to handle an event coming into the service. It has a code URI. So this is where the code is existing in the local system, or an S3 potentially, depending on where you have your artifacts. And we have a policy that allows us to actually read from the DynamoDB table. We also have an API gateway that is providing a way for us to actually call this Lambda function and have it actually retrieve data from the database. So you can see we've defined all of this in about 20 lines of code. And that's really insane if you think about it. We have access control. We have an API that can serve a request. We have a database. And all of this is mockable as well. So if you start using that SAM local abstraction, you can start mocking this for integration testing or using your continuous integration and continuous delivery pipelines. And it just provides you a nice little endpoint that you can call. And we'll get hands-on and show you how you can actually do this in the demo. But just kind of look at that and let that sink in, because that's really a lot that you're getting for a very small amount of investment in infrastructure as code. But then we kind of get into like, okay, so we have this. This looks easy, right? This is simple. We have a single API. We have a Lambda function. We have a table. Great. But in reality, even with that that architecture there, because of the parallel nature of Lambda, we saw those parallel execution environments before. We get into some hairy distributed systems challenges. So let's take a look here at an example that I've seen a lot from people who don't really understand the parallel nature of what's going on here. Let's say we have a Lambda function here, same Lambda function, just different invocations. And they're running nearly concurrently. So this one has a time of T0, the one at the top. The one at the bottom has a time of T1. So it's just a little bit behind, but running concurrently. We want to insert a value into the database. So we have a key here. And unfortunately, both of these functions running at the same time want to update the same key. So what happens here if the Lambda function reaches out to the service says, okay, I'm good here. I've received this request. I'm going to pass it along. I'm going to store it, actually persist it in the table. Key A is value B. That's great. Done. Let me tell the Lambda function that called me that it was successful. I'll return 200 status code and whatever I want to return as part of the body there. That can go wrong. Like in a networked system, there's no guarantee that after that persistence happens, that this call ever gets back to the Lambda function. Like that's in no way something you can rely on. But that's just the nature of distributed computing in general. It's not a Lambda problem. It's a distributed system problem that you might be facing today and not know it. It might explain some of the bugs that you see in your production systems that are ephemeral and kind of don't happen all the time. And let's say that this T1 call happens. So we know the state here of the initial function call. We have value B sitting in key A. Perfect. Except function A doesn't know it. But right after that happens, the second invocation comes through and it says, okay, well, I'm going to store value C here. Perfectly valid operation. If that status code had gone back 200, this would all be very normal. Keys get overwritten. That's not a problem. It gets the 200 back. It doesn't want to retry, but this function is going to retry that call. A fundamental piece of distributed systems is actually having coherent retry strategies, and it's going to try and retry that call. So how that actually happens is really going to affect whether this is a bug or not, because if we just retry that call, we say key A, value B, same payload, we're going to pass the same time along with that request, then what we're actually going to see here is, the database has now stored value B, a key A, when in fact that's an earlier write. It's a pretty big problem. That's data loss, right? Like that's one of the worst kind of bugs you can have in your system. And basically, the key piece of this that I'd like to impart is idempotency. For those who don't know what that is, that's basically asserting that the call should be stateless. Given a call at a different time, it should have the same result on the system here. So this key A, value B, time T0 or T0 call that happens later, it shouldn't be regarded by the database because it should be idempotent. If that happened after the call from T1, we wouldn't have wanted that either. Perfect. The way to actually do this in this case is, DynamoDB provides a nice abstraction that allows for easy idempotency, where I can say I want to have a conditional write. If the value is not what it was when I got the key initially, then I want to not overwrite it, and I'll return an error back to the function. Everything's great. We just return, saying a new key's been written, and it's a more recent key. That's okay. It's fine. But this is something that needs to be happening all throughout your distributed systems. And this is something that as a tester, you can really help drive within your company. And while it might seem like a complicated concept when you're starting out, you'll find it makes your systems much easier to actually reason about, because you know what the state should be. You're moving more towards a stateless architecture. And it becomes easier to reason about, even just, if you want to take it back to like a mathematical level, you can just start using, just logical functions as far as how you think about your system. And you can have provably correct systems, and it's a really cool way to address some inherent problems in the distributed systems world. And you can start doing this even at the unit test level. You can stop these bugs from ever reaching staging. Like you don't have to write a complicated test with multiple pieces of infrastructure and figuring out service table states and locking the table to make sure that this specific bug happens late. You can actually start mocking these things out and asserting a idempotency at that level. Tools like WireMock, if any of you are familiar, are a great example of how you can do this, where you can control the actual network and insert things like delays to specific clients and start reliably reproducing these bugs at a unit testing, pre-staging environment. And this is going to be a really big win as far as actually having understandable systems and the development velocity that you can gain from asserting a dependency throughout your system. Really, really great. So we have a bit of a concept on why distributed systems can be a bit challenging. Well, for a bit more context there, I didn't quite get all the pieces that I wanted. This isn't the only problem, right? Like dirty writes aren't the only problem with distributed systems. You just have a ton of different pieces that can have a ton of different states. That can have a ton of different parallel processes, a ton of different servers with just different pieces of stateful architecture. And again, the more pieces of stateful architecture you have there, the harder it is to reason about a dependencies to answer again. Cool. But as far as Lambda testing patterns go, there are some things that you should keep in mind. And this isn't the information that you'll find in a lot of places. This is opinionated information I have, opinions that I have that are shared by a lot of the serverless specialist architects that I know. And the biggest misconception that I see as far as developers getting started with serverless is the test pyramid. We have a classic test pyramid here, right? If we want to have the bulk of our tests and unit testing, we want to have a few integration tests, even fewer end-to-end tests. And ideally, we can kind of stop a lot of problems at the unit testing level, have a fast unit test suite that our developers actually use, and provide a lot of value and development velocity that way. And there's an opinion that I kind of touched on earlier with Lambda in particular, and a lot of other event-driven systems, where people suddenly start wanting to basically just do integration testing or treating the function as an individual unit, which doesn't really make sense from a testing perspective, because you can start getting these weird problems where the outputs you're testing might be fine, especially in typeless languages, where you might be getting outputs that you're expecting, but in reality, completely different code paths have been taken to get there, and they're not asserting what you think they are about your system. And unit testing doesn't have the same problem because you have these fine-grained chunks of business logic that you're working with, right? And then you can use that integration testing to actually test, the integration between services and how your function operates as a whole. And the model that a lot of people kind of move into with Lambda is, integration testing as the majority, and having, SAM, the serverless application model with its powerful little mocking library, handle a lot of the heavy lifting. And it's a mistake. It's not right, and you won't be as effective at testing, and you'll have harder problems creating test cases that reliably get the scenarios that you're looking for. You'll have an overall less robust understanding and assertion path over code flow. And the kind of implication that you have here when you're doing this is you're saying that the actual business logic is inseparable from the downstream components, if that makes sense. So when you're doing this integration testing as a majority, you're saying, I can't actually reliably test the business logic because it's interacting with other pieces of my system, and it has to be integration testing to get the flow down. And that points to a broader architectural problem. For instance, you might have very tight coupling between your services, and the service that's doing this, it might be just better suited by a queue between different services. When all you're doing is really proxying requests around and a service component, it's likely that you're looking for more of a message queue, and you'll be better served by one with more reliable guarantees and persistence and reliability and availability. So if you find your test looking like this, you take a deep look, because something's kind of going wrong. And then, we get into the kind of the same issue where we just assert the code flow for an individual set of events. Maybe I define 20 events and I say output for these events maps to these values, and that's it. That's all I need to do. It's not really great testing. It's not good practice. And you're going to kind of have these underutilization of staging environments a lot of the time, where you say that you've tested the individual components and the local integration, and you don't have great code coverage from a unit testing perspective, even if your test suites say that you have pretty good code coverage. This is also a bad smell, and yeah, it either says something bad about the application architecture or the code that you're testing, or the way that you're testing it. So regardless, it says something bad, and it requires a deeper look, and maybe bring someone else in on that to get some more insight. But one piece that doesn't really fit into the testing pyramid that's really valuable with Lambda is actually getting into performance testing. So when you think about this consumption-based model where we're paying for the actual value we're providing to our customers, then performance testing becomes a lot more useful, right? Like you can directly tie performance testing to revenue and saving money and making your system overall more cost efficient. And keeping track of key metrics like concurrency and duration can provide a lot of value. And integrating those into your test suites and your staging environment can help you stop some potentially very expensive performance regressions. And while you might say that's a decrease in velocity, it might be. And there's nothing saying you have to do anything about it. But it's nice to be able to make that decision as a business. And it's nice as a tester to be able to actively say, like, I have saved the business this much money by doing this, because if we roll this up to production, given the amount of traffic that we had go through, we would have spent X dollars. And I know when I was working in tests that those kind of wins were few and far between. Might have stopped a lot of builds, but it's hard to quantify the impact that you're having on the business. And sometimes at a higher level, it's hard to convince people that you're providing a lot of value when I think we can all agree that providing or doing testing does provide businesses a lot of value and does actually help speed up the development cycle and reduce the customer impact of problems. But sometimes that's not as visible to other people. And performance testing with Lambda is a great way to show how you're actually aligned with business outcomes. And beyond that, you can start actually testing at the integration level between the individual serverless components, or between the individual serverful components, rather. So one place a lot of people go wrong is they see Lambda as this great thing where they don't have to worry about operations and just put code in and it works. And a lot of times that's true, except when you start making these, bursty workflows that call downstream services that aren't serverless. So one common example that was a problem was Lambda interacting with services like Amazon Relational Database Service, where if you hammer a MySQL database with 500 new concurrent connections, it's going to topple over. Like it's going to. And you need to be able to actually test those integrations and figure out where the tipping point is and set up decoupling components where that's necessary. For example, with RDS, with the relational database service, we released a new service called Relational Database Service Proxy. That's basically a managed connection pool service that sits in between, that handles things like database failover and proactively routes you to the best nodes that you want to have connections to, maintains active connections when you need it. You can define a lot of really interesting pieces there that make that story a lot nicer. But when it comes to your individual application, sometimes you can show business value here by saying, well, we're moving towards this more modern architecture that's more scalable and robust, except this individual service is having problems with scaling. And I can show you with load testing, if our load increases by 20%, it can handle the load. And it's where we should modernize. And you can show some business outcomes and results there and start driving actual business value from a test perspective, which is really great. Perfect. And then we kind of get to the end goal here, where we kind of tie all of this in from a CI/CD perspective. So we can start actually delivering this code that we've tested and local staging environments with SAM local, and production staging environments with, potentially blue-green deployments or whatever your staging environment looks like today. And then we can start doing actual safe deployments to production. So we all know, you can test as much as you want to. There will still be production bugs. Eventually, it just happens. It's a reality of software, and the goal is to make them as unimpactful as possible. And services like Lambda, along with Serverless Application Model, SAM, really let you do that with things like canary deployments, where you can shift over, 10% of your traffic to the new Lambda version. And if it breaches your thresholds for what you deem acceptable, potentially like error threshold, then you just roll back to the previous version. And you don't have to worry about that deployment. It's not something you're sitting there as a tester playing that in-between test DevOps role. It's just something that, you can look back on as a tester and say, well, how do I stop this from ever getting to production again? But you've done it without really risking your whole production application, which is, I think, a really great piece of the serverless puzzle. Okay, that was a lot of talking from my side. It is a hands-on application or hands-on demo. So let's actually get to that. I'm gonna end this show quickly. If I can find my cursor. And we're gonna take a look at an actual demo here. I have a website that you can all take a look at. I'm gonna send it to Paul now. Paul, if you could share that with your YouTube channel, that would be great. Okay, I'm gonna have to switch the screen that I'm sharing, Paul. If you could manage that from the production side as well, that would be great. The screen is too big to actually be able to see what's going on in Chrome.
Yeah, I've shared that link and I've just expanded the screen as well.
Perfect. Okay. Cool. Can you see my screen right now? Okay. Okay. And Paul, if this is too small from my side, please just feel free to let me know. I know sometimes it can look a bit strange. So if everyone who has an AWS account could go through and actually look at creating a Cloud9 instance, that would be great. For those of you who don't, feel free to watch along. I'm going to work through the whole thing as well, so you can see what it actually looks like, what it feels like, and this CloudFront URL will be available after if you want to get that sorted out and work through it on your own. It should not cost you really anything as long as you have free tier on your account. You're going to be using T2 Micro and some serverless components. They're going to be well within the free tier. So that's good from that perspective. And we're going to walk through creating that Cloud9 instance now. So basically, you can just name it and testing. Whatever you'd like to. It doesn't particularly matter. You can name it, describe it however you want, but just follow that Cloud9 link there. Oh, I already have one there. Lambda testing, event. And all the defaults here are going to be fine. So we can just walk through. We're going to create a new EC2 instance with direct access, not via SSH, just via our accounts. Instance type T2 Micro. It's free tier eligible. I'd recommend that. It's more than enough to do what we're going to do. And Amazon Linux is what all the commands have been written for. If you do use Ubuntu, I'm not sure that we'll be able to troubleshoot on the stream today. So stick with Amazon Linux here. And cost saving settings, default is fine. Don't need to do anything else here. Just next step, and create the environment. So this will take a few minutes. So in that time, I'm going to talk about a few little tools that I think are very useful for the pieces that we just discussed. When you get into load testing, you don't have to reinvent the wheel. Nordstrom is a customer. I don't know if you don't have Nordstrom in Australia, so I have to show you. They have a nice, smooth little website here. Don't get to know my location, Nordstrom. I'm sorry, but it's a really cool serverless-based application, and you can see that they have a serverless artillery here, where they basically have given you this tool that allows you to load test your individual serverless functions. And if you look at the actual syntax here, it's really not that bad. Yeah, let me find it for you. I have this on my larger screen. It's quite easy. Invoke. Yeah. So you can just invoke this load generator, and you can define how you want to actually, how much load you want, which paths you might want to target an API with, what API you want to target, that sort of stuff. And you don't have to reinvent the wheel there. Cloud9 should be done. We'll talk about a few others in a second. So now that Cloud9 is done, we can shift through to actually talking about the deployment frameworks. So there's a script here. We'll copy that. Basically, all it's doing is pulling in a CDK application, a Cloud Development Kit application, infrastructure as code. And we're just going to take that in, unzip that application so it populates in our Cloud9 environment. And we're going to install the packages that it needs. And then we're going to install Jest, which is a Node.js testing framework. So for those who don't know, Jest is one of the more popular Node.js testing frameworks. It allows you to really easily create test suites, get like code coverage results, has a lot of very nice mocking functions built in. And we'll look at one of those today, where it has built-in mocking functionality for DynamoDB. And you can do that at the unit testing level without even having to work with SAM. And then we're just going to install a dependency that's missing from the default Cloud9 environment, which is the Java 1.8 Java runtime environment. And remove Java 1.7 because otherwise the whole thing does not work. So please copy the whole script and just run it in your Cloud9 environment. So I need to actually pull this up because there's a little piece here that's actually blocking my view. There, I can drag it away. Okay. So it looks like there's a bug with the copy functionality. You might have to copy through the remainder of the pieces here if you click the little button like I did. Just to install the dependencies for both the main package. So this is the CDK application is the one that's at the root level here. And then the serverless application, that's actual Lambda function is in here. And we'll take a look at both of those and show you what they actually look like. Cool. Should be done in a second. Lastly, we're going to install Jest, the test framework, installing it globally with this little -G flag so that we can run it from the command line. If you get any errors about it not being on the command line or command Jest not known, it's because the -G was missing here. And installing Java. So while we wait for that to happen, basically, we'll take a look at what the CDK actually looks like. So if you expand that lib folder, we can see how to define a stack in the CDK. And basically, what we have here we have a flight table, which we're saying is a DynamoDB table. This is going to store some flight paths. So we'll have paths from one airport to another airport and a cost. And we'll have a primary key that's the origin, and we'll have a sort key that is the destination. So basically, if I wanted to fly from the Sydney airport to the Melbourne airport, I'd have a route there, and the destination there would be the sort key. So if I wanted to get all of the flights that fly away from Sydney, I'd be able to query there. And if I wanted to restrict to just flights that go from Sydney to Melbourne, I'd be able to do this, to use both keys. And after that, we have this little flight adder here. You can see this is how we actually define a Lambda function. We tell it what method we're going to call. So when we look at the Lambda function, you'll see it has a method handler, and its name is index.js. And we give it a runtime. So in this case, we'll be using Node.js 12. And we tell it where to find our code. So you can see I'm just saying it's in the same folder, flight adder. It's all here. And tell it how long before it should time out. And then we also give it the name of the DynamoDB table. So at runtime, it can use this environment variable to figure out which table it should be calling. Cool. And if there are any questions, feel free to interrupt. Happy to answer a few there. So we can see that command just finished running. Oops. And now if we do Java minus version, I should see 1.8. So basically, we also have this little Lambda function here we'll talk about in a second. But to show you guys what unit testing that would actually look like, if we just, CDN, if we just do npm test, you can see it's going to run this command just. This tells it to run a test suite. It says returning the test suites to run. It's going to run through. Oh, I have some failures. So it's saying that the flights are not being persisted. So we'll take a look at this in a second. It's really hard to see in this because I have basically really zoomed in so it's visible. We'll get that done in a second. But okay, so that's what running the test actually looks like. And then if we want to see how they're actually defined here, we talked about the CDK. Oh, this makes sense. The problem here is I skipped a step in the instructions, so don't be like me. Actually read the instructions I wrote. And we need to go to the environment. So if we cd to environment and CDK sync, this basically tells the Cloud Development Kit that we need to make a CloudFormation template. So this is all just an abstraction on top of CloudFormation as well. And we just tell it how we want it to look. So you can see we have the CDK.out folder now. And we have an actual template in here now that shows you, here's a DynamoDB table. It has attribute name, has a range key, has definitions of types of the different attributes, has throughput capacity, has a lot of different stuff. So you can see, that 20, 30 lines of Cloud Development Kit generated 154 of the template.json. But the really interesting thing here is that we can actually test this generated template with SAM. So we can use the Cloud Development Kit and SAM together, or we can use both independently. Like if I wanted to deploy this with SAM, I could as well. But to show you a bit of what that looks like, we can actually just go through and say, okay, I want to actually do a local invoke on the Lambda function. So if you look at the syntax here, we do a SAM local invoke with a target of the template. So this is the template we generated, or the template file of the template we generated. And we give it an event here. So if you haven't looked, we have this events folder that basically just defines a few sample Lambda events that we might use for testing. So, have some sample cases like, having flights that are null, having an empty array, entirely empty event, just kind of standard edge casey kind of things. But these are all valid Lambda events. Lambda events are just JSON. All you're doing is passing the service in JSON as the event, and it's executing code on it. So in this case, if I run my SAM local thing here, then I'll see that for this event, IID to PDX, Virginia to Oregon, Portland. I can't remember the airport code for that. It basically returns saying, it's the updated list here is it's updated routes for IID to PDX. This is the return value of the Lambda function that we provided, and we'll dive into that in a second. So you can see we've used a few different deployment mechanisms here just to kind of show that they're all sitting on top of CloudFormation. You can use all of them together. There's no real winner, I think, yet. I personally prefer the Cloud Development Kit immensely. I think it's a great tool, and I really enjoy it. I know a lot of people who are just very used to SAM and want to stick to making these serverless templates. And if you take a look at what we've done, it's about the same as that example that was 20 lines and the PowerPoint. So it's not like there's a huge difference in between the two. There is when you start getting into more complex architectures. I think the Cloud Development Kit is better there. But for things like this, use what you want to use. The real key takeaway is that you can mock the template environment with SAM local, and you can use that for your integration tests. So to show you what's actually happening in this function, so we can get a feel for what's actually being tested. There are comments all through here, so if you want to skip through, feel free to move more quickly than I am. But we have one piece here that's a bit aware of the fact that it's being tested. Not my favorite thing. In another language, I'll probably be using dependency injection to work around this. But in JavaScript, this works just fine. We say if there's a worker ID in the environment, we know that it's being run by Jest. So we'll use a different config. So in this case, we say, okay, well, if that's true, then we will use this config here, where we actually target a localhost endpoint. We don't enforce SSL, and this region is just clearly a fake region that's just there to satisfy the parameter constraints of the constructor. And if there isn't just worker ID, this creates as normal. So it's pretty fine. Our handler function, really straightforward. We call one thing here. We just add new flights. It's not a remarkably complex use case. And then when we're adding new flights, we do a few different things. And a lot of these have been done just to make room for testing and unit testing, that sort of thing. Like, for example, here, we go through and we detect duplicate flights. We don't really do anything with it. It's just another way to unit test a function. We go through, we take the unique flights, we process the flight list, and by processing the flight list, we wind up going through and making sure that the individual flights are in a nice format for us to update. And then we push them to the database. After that, we return these updated flights, and we want to get those back as a return value. So we do a little bit of working around the fact that it's a map, and maps aren't serializable by default in JavaScript, and return an array of flight entries there. There are a few different things you can do there. This is just to kind of give you an idea of what's going on. And then we have our little helper functions here that work along the way. So here we just say, it's a lot of text to basically do null or empty checks, and then say it needs to have these three fields, otherwise we throw an error. And then the actual update database call, this is where, you probably want to have some integration testing, work through there. This calls out to DynamoDB in production, and not in production, it just goes through and calls the localhost endpoint that's been created by our Jest mock, or SAM, depending on how we're running it. We'll cover all of that in a second. And then For the duplicate flights, it's exactly what it says it is. You just work through the duplicate flights, go through, make a set, check to see if the set is the same size as the array. If it's not, then we throw an error. If there's an empty flight list, we throw an error. Shouldn't happen because, the upstream does it already. Anyway, basically, this is all pretty straightforward. Cool. So and if you're not familiar with Node, there's a lot of syntactic sugar around here where you have async and await. Don't worry about it too much. Just understand that it would allow us to do parallel processing if we wanted to. In this case, it's not really something that's necessarily useful. Perfect. So here's where we actually run those tests. So if you remember earlier, we did this npm test. npm is just the package manager for Node. It also manages some scripts. Here, the only thing we're really calling is jest. And you can see we have a test suite here. We have some test cases. You can see the amount of time it took, 4 milliseconds, 1 millisecond, overall a pretty speedy test suite. And we have 6 tests that have passed, and overall it took us 1.8 seconds. So not too bad. And to see what they actually look like, it's exactly what you'd see in a typical unit testing environment. Here we have a group of tests. These are all related to testing the deduplication. We make some simple assertions, like here we say, for a flight list without duplicates, it should equal the input event. Fine, all pretty straightforward. And here is where we kind of start to get into some more interesting pieces. So this is where I mentioned that the testing suite that you use really does kind of have an impact on how smooth this is going to be. One nice thing about Jest is it comes with this Shelf.io DynamoDB mock that basically uses a flat file in the file system to mock database access. And it's not quite the same thing that Sam is doing. Doesn't quite test the same thing. I can't do this and say it's an integration test, but it does let us actually work without defining mocks for DynamoDB. That would probably be a bit silly. They'd probably just be, I put stuff in, I get stuff out, there's a map behind it. Doesn't necessarily test all the async behavior that could be going on behind the scenes. So one nice thing here is, we get to use that configuration that we showed at the beginning. Basically here, it's just a simple pre-processing step where we go through and just assert that the mock database is empty before each test case. And then we just use the database as normal. These are very standard unit tests that access databases and make some simple assertions. Cool. If there are any questions about the unit testing, feel free to let me know. If not, I'll dive into the integration testing, which I think is a bit more interesting. Okay, I don't hear any shouts, so I'm gonna keep on moving. The integration testing here is pretty interesting because this is where we start actually using SAM. And you'll see here we have this conditional before this test suite is run. So you'll notice in a second, after we change the workflow, that the actual test stack here, that the actual test suite that we just run isn't running this individual test because if we check, it's not defined. But we can bake this into our workflow like we would if we were in a CI/CD environment. And here I've defined npm start to basically set up SAM local and start a mock Lambda endpoint here. So if you take a look, you'll see that this Lambda constructor is accessing localhost. And again, same thing, we're disabling SSL, we give it a region, but we actually call the invoke APIs. And it actually goes through the same process that API would in the SDK. Same parameter validation. It goes through all the nice little code paths there. And Funnily enough, if you take a look at what happens if we do npm test, that new integration test suite is going to run, and you'll see something new this time. the demo curse here. npm start. Start, and let's see. Yeah. Just for the sake of showing you, we'll do that quickly and then do npm test. Looks like I didn't push the latest version of my script into there, but you'll see. So here's the more recent part. So we have a few failures there, but I think that's just due to messing around with the start and stop over and over again. But the Docker environment here, you'll see we have logs here where basically we start pulling this Node.js Docker container image, we mount that, and then we actually process the flight. We get the function logs here, and we get the return value that matches our expected value for the event that has a flight from IID to PDX, which is pretty interesting because the cool thing about this Docker container is it very nearly matches the production environment. The same way you'd use Docker in a traditional testing method, the Docker container that we're using here has the same underlying shared library dependencies, has the same underlying operating system, and it very closely mirrors the actual production Lambda environment. So this sort of local staging can actually get rid of a lot of errors that never have to go to your actual production staging environment. So here, let's just get rid of whatever's happened here. npm start, cd flight addr, npm start. And just see if that actually runs. Cool. Yeah, so basically, this allows us to do a few interesting things. And you can see we can kind of mix the models here, where we have SAM running the mock, we have code generated by the Cloud Development Kit, and we can really deploy however we want as well. So let's say maybe this satisfies what we wanted to do for local testing, and what we really want to do now is actually deploy this. It's really straightforward. So I can just do a CDK deploy. Because I've already deployed the stack in my account, it's probably going to look a little bit different than yours does. And because I've already bootstrapped, I'm not going through the exact steps there and the CDK basics here. But yeah, if you run this, your account you'll be able to actually do a CDK deploy. And beyond that, if we just actually take a look at what's actually going on here, we have the individual scripts. Oh, here's the CDK workflow. That uses assets. Oh, I'm not bootstrapping this account. That explains a few things. So this bootstrap basically just creates the infrastructure you need to have interoperability between the higher level abstractions in the CDK and the lower level CloudFormation. So things like having S3 buckets to store Lambda assets, or to use as intermediate value stores, and it's pretty cool stuff. But it does need to actually create these individual buckets and things like that to actually work. So while it's going through, we'll take a look at the actual script. So you can see the way that we're actually starting this this workflow is just by having a SAM local CLI call. And we say start Lambda, which basically starts the mock Lambda endpoint. And then the template over here is just the template that we've sent earlier. Test is just a wrapper around the word jest. I mean, we can really do either. And stop, all it really does is turn off the integration test piece here and does a looks for whatever process has an open port that corresponds to the open Lambda API port there, and gets rid of the process to clean it up. Basically, after that, we're able to go through, do some npm tests, and you've kind of seen that workflow already. And we've taken a look at the test suite code. But now, if you are at the point where you have some stuff in your account, then a pretty easy exercise would be to actually just add a new test to your index.spec. So each one of those spec files, like, if I made another spec file here in the test folder, would correspond to another test suite. So, maybe I have, a test suite that corresponds to business level concerns and a test suite that corresponds to marketing concerns, or I don't know, depending on what you're trying to do with these flights. And defining a test is really straightforward. So all we do is say, we have a test, this is the description of what it does, and we have a function that reads in an event from the event folder and basically passes that event to whatever function we're trying to test. So in this case, detect duplicate flights. And if we wanted to add that totally within the realm of possibility, we can just go through and add it to the deduplicated flight list tester. It's going to annoy me. Take that back and save the file. So make sure you save the file, otherwise there's not going to be any test there. And from there, we can just go into that folder again, the flight added folder, and run npm test. Cannot read property cost, undefined. Sometimes the underlying file store can get a bit corrupted with the DynamoDB mock for jest. Basically, the way to work around it would be to have better async await handling in this test suite. So to really assert these tests aren't running in parallel, because it can cause issues with the underlying file store. Because all that really is there is just a backing flat file for the local DynamoDB mock. Oh, what am I doing there? cd flight adder, npm test. The true demo cursed here. Happy to update this with the correct code after the workshop's done. Very frustrating because I ran through all of this about 20 minutes before the demo started, but that's life. And as far as the mock for DynamoDB goes, we can also take a look at adding another test there and taking a look at what's actually happening. So you can see here, we are trying to work around that flat file synchronous access issue, where you can have some corrupted data. So we basically do each of these calls synchronously. where in reality it shouldn't particularly matter. And if we just add that to the DynamoDB section there, and honestly, it looks like might be that the might be that the node version isn't consistent with when I tried it. Trying to use import after just environments been torn down. Yeah, so the DynamoDB tests just aren't working right. The other test suites are, the other tests in the suite are working fine. I'll give you an updated piece of code there to work on that later. But basically, you can kind of see how the workflow actually looks. And then after that, if you want to actually go through and add another integration test, it's really trivial to go through and say, I want to add a new, I want to add a new event to the payload. The only thing you really have to change to get that event level testing that we were talking about before is this payload here. Everything else should be the same. And that's not going to work because the function name has to be dynamic based on the CloudFormation template. But basically, yeah, this is how you'd work with the mock. Again, we assert the SAM process has been started. So if we look at that npm start again, basically we're just making sure that this has happened and is running in the background. And we can build out some pretty interesting test suites using these applications. Cool. That's basically what I had today. Are there any questions based on the content? Oh, sorry, I shouldn't be here. I'm going to stop sharing my screen quickly just so I can see if there's any engagement because I have all my other chat applications turned off. So stream's not going off, just seeing what's going on.
Hi, Rob. There haven't been any new questions since you've gone through that part. I've mentioned in the on the screen that if people want to add new comments or make new questions, we can either, I'll let you know. Yeah,
and really around anything. If you have just serverless specific questions or CI/CD specific questions, I'm happy to answer. Whatever is on demand. If not, I'm happy to call it as well.
Oh, thanks. Let me just approach the chat and say, are there any new questions that people would like to ask as we move into the question and answer session? There was one question in the past that was asked by your colleague Igor, which was, how do you sync the whole architecture when errors happen in one function and you have lots of distributed functions like a rollback path? That was a question that was already answered by your colleague. I'll just show the question for that.
Mm-hmm. So
and the response was, the response was there's an AWS service called X-Ray that can be used to trace requests across Lambda functions. Functions can also be assigned to DLQs so that when requests fail, those events can be persisted and dealt with appropriately. So there are really multiple techniques to address synchronization and or integration. Oh, I got some comments as well. Yes, how do we, this is from Mahesh, how do we integrate tools like LoadRunner to conduct performance testing?
So the key thing to keep in mind is that what SAM is providing you, or what CloudFormation is providing you, is really just an environment. You have an API You have a Lambda function. It has downstream resources. It has the integration tests you define. And if that load runner can target an API endpoint, which I'm assuming it can, haven't worked with it personally, then it should integrate the same way that any other API does. And
right,
so
thanks.
I haven't really touched on that. This is actually a good point that I meant to speak about in my talk, where one of the nice things about testing Lambda is you don't actually have to have these staging environments with a ton of test servers just pooled around. If you need to do a load test once a month, all you do is you run the load test and you pay for the load test at that one time during the month. You don't have to over provision an expectation of running the load test in your staging environment and seeing what's going on, if that makes sense.
All right, thanks. We've got one more question. First of all, some great comments. Great presentation, thanks. Great content, Rob. Very well received presentation. A question from Josephine Archibald. Any recommended materials to show how to test serverless apps?
Recommended materials for how to test. Pretty much everything you're going to find is going to be related to SAM. So if you YouTube, search other videos, it's all going to be serverless application model related. And again, I think that's a mistake. I don't think that that's how you should be thinking about it. You can easily get led on that path, and I'd like to reiterate, not a great thing. Basically, I just get back to the point that essentially what you're doing when you're testing serverless applications is just testing distributed systems. And anything about distributed system design is going to come, in your favor here. Books like Designing Microservices, talking about, from a development perspective, how to architect those and the considerations that your developers should be considering, can give you a lot of perspective. And likewise, just being aware of how unit testing is best done in your framework or in your environment of choice is going to really serve you well. That's what I'd recommend. Sorry, I do not have a better answer there.
Oh, well, thank you. It's pretty good. Can I just ask if there are more comments? If anybody else who wants to add any more questions before we wrap up, please do so in the chat. This is your last chance.
I realized I do have 2 more useful tools if we want to just cover those before we work through.
Okay, go on, yeah.
I should share the screen actually.
Actually, can I just ask one question beforehand? Yeah. There's a question from Mahesh again, and then we'll move on to that. How do you profile to deep dive Lambda serverless? Should we use X-Ray and other profile tools?
So I really like this question. It depends on what you mean by profiling. If you mean observability, X-Ray is 100% the service to look for. If you want to get these trace records and correlation IDs, middleware might be the right way to work through. There's a tool for Node.js called DAZN Lambda Power Tools that basically allows you to have a middleware that inserts these correlation IDs all the way through your serverless workflows. And don't necessarily need X-Ray for that, but it lets you kind of aggregate those, and then using other tools, you can get the logs associated with that correlation ID, which is really powerful. But if you're just talking about actually profiling your code, like understanding performance-wise what's going on, again, you can use the actual language-specific tools to generate things like function heat maps for figuring out where you're actually spending time. X-Ray can also do very similar things where you can define small subsegments to figure out where your function's actually spending its time. And it can do this on a sampling basis as well. So you probably, in production, even in staging, don't want to do this for 100% of calls, because it can slow things down. It can be a bit expensive. But by default, X-Ray samples about 5% of calls, if I'm recalling correctly. And that can be really valuable when you're trying to figure out, what's going on in a distributed system where, you might have a chain of calls, 10, 15 calls long.
Okay, thanks a lot. Appreciate it. Just to introduce, you wanted to talk about two new tools. Shall I share your screen again?
Yep, I will throw that on right now. Here we go. Give me 1 sec. There, should be good.
Add to the screen. There you
Yeah,
go.
it should be the cool. So this is one tool made by one of the developer advocates. Really useful tool. So basically, when you do start looking at serverless workflows and actually getting costing down, this is a really interesting tool that basically has a step function, which is a serverless workflow orchestrator that goes through and executes your function to figure out, well, where exactly is the optimal cost point as far as resource allocation. And for instance, here we can see that the execution time is the lowest here and the execution cost is the lowest here. So this is the optimal memory allocation for our serverless function. And when you start looking at things like making this 14% cheaper to run, and this, it's gonna cost you very little to actually deploy this and run this. It's a great useful tool called AWS Lambda Power Tuning. And then the other one, I mentioned it in the previous answer about observability and profiling. DAZN Lambda Power Tools is a really good middleware technology that you can see has some pretty active development. Has CI/CD, so you're getting at least something tested in here, and commits from 6 days ago. But basically, it allows you to hook in and do some simple things that you'd really want to do, and not have to rewrite every time you do a Lambda function, like get correlation IDs to see what's calling what and where it's going, and figuring out when debug logs should be turned on, handling obfuscation of personally identifying information. So if you have fields that are PII, you can make sure that those don't get transmitted to avoid compliance issues. And a few other interesting ones would be basically the MIDI underlying library that this uses allows you to do things like error handling that maps back to HTTP response codes. So instead of having to catch all the errors and map them back to 400s and provide descriptive errors, it's just you make a simple method call. And these middleware libraries are very powerful for just getting proof of concepts off the ground and for tracing and observing your functions in production. Oh, I keep going back to that. Cool.
Really appreciate it. Thanks. I don't think there are any more questions. We had a great comment from somebody called AKS. Thanks, Rob, Paul, and Igor, for a really good presentation. We appreciate that. And thanks, Rob, really, and Igor for providing some wonderful content and a great presentation.
Cool.
Helping out with questions.
Yeah, no, I really appreciate the platform, and thank you for watching.
I understand that there's a particular link that you want me to send you for.
Yes, I don't have it available right now.
Thanks for coming on the test. It means a lot. Just this thing that Rob said before, there is going to be a feedback form that you'd like to post, which we'll post in the comments to the YouTube video and also on to Meetup itself. So please fill that in, and if you like the presentation, it's I think a wonderful presentation. We've had some great feedback and a decent turnout. So, well, thank you so much, Rob.
Thanks again for the opportunity. It was great. Cool.
Okay, signing off, everyone. Good evening.